Okay, at the end of this session today, you should be able to, number one, explain the different chemical reactions that can occur at different speed, as well as a different method to investigate the speed of reaction. Alright, so as we all know that there are different types of chemical reactions. Some of them are very fast, some of them are pretty fast, and some of them are really slow that can take up to years for the chemical reaction to be completed. Right, so then how do we measure the speed of reaction? Okay, now the speed of reaction tells us how fast or how slow the reaction takes place. So basically, how can we measure the speed of reaction? We can measure by the amount of product that has been formed, or we can measure the amount of reactant that has been used up. Alright, and as you know, whenever we talk about speed, we need to measure with regards to time. So therefore, speed of reaction is equal to the amount of product produced, alright, over the time taken, as well as the amount of reactant used up over the time taken. So how do we measure the product? Alright, in this case, if we measure the volume of gas produced, we are now actually talking about the product. Okay, so let's consider this, the reaction between calcium carbonate and excess hydrochloric acid. We can set out the experiment like this as shown, and this is a chemical reaction. So what exactly are we measuring? We are measuring, okay, the gas over here as carbon dioxide. And as you know by now that carbon dioxide will escape as a form of bubbles. So let's take a look at this experiment. Alright, what will happen is that this animation will show you what will happen when calcium carbonate reacts with hydrochloric acid. Take a look. Right. So what do we realize over here? Initially, the bubbles is very vigorous, they are vigorous bubbling, and towards the end it actually gets lesser and lesser until you reach 0. So what will happen is that the gradient of the graph, okay, so what happens is that the gradient of the graph, okay, actually tells you the speed of reaction or the rate of reaction at that point of time. Okay, so what will happen is that you realize the gradient actually gets less steep as time progresses until it reaches 0 gradient. Once it reaches 0 gradient, it means that the reaction has already ended. Why is this so? This is because the amount of reactant alright, the amount of reactant is actually getting lesser and lesser. So therefore, alright, the rate of reaction actually decreases. Okay. Alright, so that's one way. Another way for us to measure is to measure the change in the mass. Alright, and in this case, what we're talking about will be the reactant instead. Right. So example, again, when we set out the reaction between hydrochloric acid and marble chip, which is actually your calcium carbonate as well. So what will happen? Okay, what we can do is that, okay, we can actually measure the mass loss of this thing. Alright, so why is there a mass loss? Because carbon dioxide has escaped from the conical flask into the environment. Alright. Okay, and why is there a need for cotton wool here? The cotton wool is to allow the carbon dioxide to escape and yet preventing any acid spray. Alright, because as you know, there will be vigorous bubblings. Alright, and this to prevent the bubbling from any spray, alright, from escaping. Okay, so what will happen? As you can deduce, over time, alright, the mass of the reaction will get lesser and lesser, and if you draw a gradient by the side, you will realize that the gradient is actually getting less steep. Alright, so same explanation for the first part, but in this case, this will be in terms of the mass loss. Alright, and the gradient gets less steep, signifying that the speed of reaction is getting slower and slower. This is because the reactant has slowly been used up. Alright, until it reaches the horizontal plateau, which means that the reaction has stopped. Alright, which is in this case over here, the reaction has stopped at 8 minutes. Alright, so now that we know how to measure the speed of reaction, we need to know this concept known as the collision theory. This forms the fundamental of our understanding for the speed of reaction. Alright, so in order for a chemical reaction to occur, these two things must be must occur. Alright, so when particles, I'm talking about either in atoms, molecule, or ions. Right, so basically what will happen is that in order for chemical reaction to occur, both particles must collide with each other at the right orientation and collide with energy that is equal to or greater than the activation energy. Alright, so now what happens is that we have learned this previously before in the energy profile diagram. Alright, so this will be your reactant, alright, and this will be your product. So in order for a chemical reaction to occur, number one, it needs to have energy greater than the activation energy, right? And that's not all. The particles must collide at the right orientation in order for the chemical reactions to occur. Alright, and when these two conditions are met, this is known as the effective collision. Alright, take note, you will need to know the key idea here is effective collision. We will be using very often this concept of effective collision in our chapter, right, in our future chapter stuff. Alright, that's all. Thank you.